In this video, we are going to find the most recent orders of each product. Hello, this is Jagan from Growth Data. I am posting this video to share my knowledge in SQL with you. If this assists you in your interview preparation anyways, I will be happy. Welcome to the 39th video of our Advanced SQL 50 interview question series. We have different topics to cover and we are now continuing with our questions on subqueries. This video will be tagged in Advanced SQL 50 questions playlist and the code we discuss in this video will be uploaded to the GitHub. The link for the GitHub page will be in the video description part. Now let's see the data and we can talk about the question in detail. So we are given three tables. The first one is the customers and then the orders and the products. The customer table got a customer ID and the customer name. It's like a lookup. If you have a customer ID, you can find out who the customer is. And then the products table. Same like customers, if you have a product ID, you can see what product it is and what is the price of that product. The main one is the orders table. So whenever the customers makes an order, we track each order with a unique identifier, which is the order ID. So this order ID will track on which day we ordered the product and who is the customer who ordered the product and then what is the product. So this is what the given data is. Let's create this table. So what they're asking us to do is we have to write a solution to find the most recent orders of each product. So if you see this data, let's move it down so we can manipulate this. So I'm going to create three sets. So for based on the product. So this is one. And we got 3 is here and we get 2. So we got 3 set of products, like 1 and this one is 2 and this one is 3. So what they're asking us to do is find the latest date for each product. If you see this, July, August, and this is August 1st. So this is the latest, and we got 2 products or 2 orders for this product. And if you see this, this is July, June and August. So August is the latest. Here August 7th and 29th. So 29th is the latest. On seeing all this, we find 4 records or 4 orders which falls under the condition. So we have to say what is the product name, the product ID and the order ID and when we ordered, right? So we got for product 1 is keyboard, right? So we have 2 records. For keyboard, we got 2 records. Order is 6 and 7. So order ID is 6 and 7. And the date is 8/1. And the second product 2, which is a mouse, and the latest one is 8/3. So 8/3 is here and it's a mouse. Order is 2 or order is 8. The order ID is 8 and product ID is 2. And the last one is product 3, which is a screen, and we have August 29th as the order date and it's done by customer 3 and the product ID is 3. So we track all this information. So this is what is expected. So first thing is how you connect all these 3 tables to get the information, right? Let's see the order details first. That's the main table we looked into, right? So take the order table, select from orders. So what are the columns we have in order table? Order ID, order date, customer ID and product ID. So we say order as O, so it's O dot. It's always good to have alias name when you join more than one table. So we have order table. When I run this, it got the order ID, the order date, who's the customer and what is the product. We have 4 columns for this. Now for the order table, if I want to know who is the customer who bought it, I got the customer ID here, right? I want to know the customer name. So how will I join? So I will just add inner join. Understanding is whatever the customer ID in the orders table, everything should be in the customer table. right? If there is something missing in customer table, that's a data issue. So we say customer join, so inner join customers customers say C, and we join based on the customer ID. C dot customer ID is equal to order dot customer ID. Now I can get the customer's name. So customer name, the column name is going to be name. C dot name as customer name. If I run this, for every customer I get the name: Winston, Jonathan, Annabelle. Okay, now I got the, for order, who is the customer and who is the what's the customer name. Now I want to see the product name. So I have the products, and the product name is in the products table, and it's going to be product name. Okay, so I am going to again do an inner join, the understanding that all the product ID should be in the products table. Products table, say P on P dot product ID equal to the order table dot product ID. Now if I want to get the product name, I say P dot product name. I don't want the IDs, so I can just disable this. So now for every order, the date and customer name, and I got the product name. So this is how I join all the three tables. But when you see the output, it's asking only the product name, product ID, order ID, and order date. So there's no need for the customer name. Though they gave you the data in the question, doesn't mean you have to use that. If they ask for the customer name, then you can bring in the customer table. But here they haven't asked anything about the customer, so you can ignore the customer table. Okay, so this is the basic way how you join all the three tables. Now let's go to the question. First we have to find the most recent order. For that, what will you do? Select from the orders table O, most recent is for every order ID. Okay, overall I can start with, right? Order date will give me all the dates of the order. If you want to find the most recent, I can simply say max as order date. So that will give the most recent, but we have to find the most recent for every product. So I am going to add O dot product ID, and for every product you give me the latest date. So since I use max with the non group by columns, so I have to use group by the non aggregation columns, right? O dot product ID. So this will give the breakdown of for every product what is the latest date. So if you see this, for 1 is 8/1 is the latest date, and for 2 it's 8/3, and 3 it's 08/29. So 8/3 and 8/29, all is good. So instead of saying the column name, I can simply say the column position, even that works. So here I figured out, so what is the latest date for every product. Now I have to bring in the product name and the other informations, the output. So what I do, same like the previous question, we are going to create a CTE table, and then we are going to use that for filters with raw data as. So this will give me for every product what is the latest date. I'm going to use this for the orders table, inner join raw data raw data r on r dot product ID equal to orders table dot product ID. So here I want to get product ID, and then we have to bring the order ID, right? Product ID, order date. O dot order ID, O dot order date. So if I run this for all the products, I will get the information, but I want to get the matching order date. The maximum order date should be the one I look for. So I am just going to add one more condition, and the raw data's order date, which is the latest date, should match with the order table. Bring only those records. So when I run this, I get for 1 it's 6 and 7, right? For 1 it's 6 and 7, and for 2 it's 8. Yeah, 2 it's 8, and for 3 it's 3. So we got the corresponding order and the date, the latest date. Now I want to bring in the template here. I want to bring the product name. To bring in the product name, I simply can join product table, PU products, which is P. So that connects with the product ID. Product ID equal to order dot product ID. So I can add the name in the beginning. P dot name as product name. No aggregation, so no group by. Unknown P dot name. So what is the product name? Okay, this is not the name. P dot product name. Good. So I got the product name, the product ID, order, the latest order details, right? So this is a CTE logic. Same like the previous video, if I do a CTE logic, I can remove the CTE table and make it as a subquery table, or I can do a correlated subquery or a concatenation or the Windows function. The 5 options we tried in the last 2 videos, we are going to do the same here. We keep this as the reference. You can say approach 1, which is the CTE table, and let's comment this out. I'm going to use the same code here. Since I use CTE table only once, I don't have to explicitly create a CTE table. So I can create a subquery table. So instead of raw data, I can just replace that with the code. For better understanding, I can do some formatting here. Okay. Now if I run this, I get the same result. Only thing is, instead of CTE, I just did a subquery table, which brings the same data. Okay. So this is approach 2, which is a subquery table. And the next one we going to see is correlated subquery. Correlated subquery is nothing but the main table drives the subquery part. Let's see. From the order table, we can join the products table to bring in that, and then we can simply say and the order date, O dot order date is equal to, we have to find the maximum of order date, select maximum of order date from the orders table. You can say O, this is O, where O dot the product ID is equal to the main tables, O dot product ID. So for every product in the main table, so main orders table, that will trigger the subquery and get the maximum of order date, which has to match with our main query. So if I run this, it gives me the same part. Why is it? Product ID equal to product ID. So I have to get the order, product, and the order date equal to, get the order date from this. So what am I missing here? It should not bring in all the parts, right? Okay, it's duplicating. 1, 2, 3. Why is it duplicating? products table, it gets it, and o dot order date equal to, oh, I haven't put, okay, o dot product id equal to o dot product id. Okay, everything looks good. Only thing, okay, so here we put o dot order id, which is going to match the main order. So you have to put o dot product id, typo error. So when I run this, I get only those products which got the maximum order date. So previously we just referred only the main table. So all the records came out. Like if we do the reference to the main table, all the orders 1, 2, 3, 4 to 10 came. So we have to supposed to bring the subqueries order date, right? Okay. Now we got the third option, which is the correlated subquery. Approach 3 is correlated subquery. No, sub, not ab. So this is our third approach. The fourth one we saw is the concatenation, right? So concatenation part, let's use this code. Instead of using the correlated subquery, we can say the product ID and the order ID. The combination should be in the subquery which brings the oo.product ID. You can say bring it here. oo.product ID max of date group by 1. So this is the first subquery we tried, right? Select the product ID max of date. So every product it gives the latest order date, and then that format should be matching with the concatenation part of the main table. So if I run this, I get the same result. So the main query parts, we tried the CTE table where we got the product and the maximum order date for each product. Then instead of CTE, we tried the subquery table. Then we replace the subquery table with the correlated subquery where the main table triggers the subquery. Finally, we just concatenate the product and the date and get a subquery with all the combinations provided the order date is the maximum date for that product ID. These are the four main things we use for the normal SQL. But if you go for the Windows function, then we can do the same logic here. We can get the order and the products, and then we are going to sort based on the rank part. But you see the difference between the row number, rank and dense rank. Let's see, row number over partition by for every product, right? So o dot product ID order by the date, o dot order date, and we need a latest, so we get descending order. So if I run this, so for every product ID and order, I put the rank and partition by product. So for keyboard, we got 4 records. The first one goes with 8-1. Since I got 2 records, if I say row number, I got 1 and 2 because it just gives a sequence for every row. But I need, if there is more than one product the same date, I have to bring in both. So row number is not the right option. So we give the rank. So rank is a good if you take the first option, right? But if you see this 1, 1 and they skip the 2 because we already got 2 rows, right? So row number skips the sequence if there is more than one rank before. So I want to go with the dense rank. Rank works fine here, but just for cautious option, if you have to go with 2 or 3, better use the dense rank. The dense rank, if there is more than one record, it just carry forward the sequence 2 and 3, right? So dense rank is a better option. And again, we talked about the qualify function. Qualify or num equal to 1 will give the answer if provided the database is Snowflake, Teradata, Hive, and whichever supports the qualify function. Since MySQL don't consider the qualify, don't have the qualify option, we are going to create a CT table with raw data as. We take this data set and we simply say select the product name, all this, the alias name, make it constant from the raw data where the row num equal to 1. Actually, it's a dense rank. You can say rank instead of row num. Rank equal to 1. So when I run this, it will get you the disconnect from the code. Okay. So we have to create the table again. Let's create the table. Run this. Customers already exist. Okay, let's restart this. Okay. You have an error creating this table. Okay, there is no semicolon here. I have to download some or install some database directly rather than using a coder pad. Okay. So here, oh, this one is not required, right? So we can clean up this. Is from here. So I clean up this and we restart. Unknown column product name. Okay, that we can deal with. So raw data, we got product name, t dot product name. It's here. O dot product name. Oh, I haven't gave the alias name O. Okay. So I got the same result for the Windows function. So even if I say rank, it's going to work in this scenario. But if I say row number, I'm going to miss one record from the keyboard because it takes only one row number. So we got only 3. One is missing. So I prefer go with the dense rank as a better option. Right? So 1, 2, and 3. So all this code will be in the GitHub. So if you go to the video, this will be in the advanced SQL 50 question series. And if you go to the description part, there's a GitHub link which will take you to the code base. The one we are seeing now is the 39th video. So that will have the create statement and what is expected and the 5 options we have: the CT table, subqueries, correlated subquery, concatenation, and the Windows function. You can use this for your practice. If you want to join the WhatsApp channel, there's a channel link here. You can use this and join Growth Data WhatsApp channel. I will be posting the short videos and tips in this group. I try to be consistent, but yeah, most of the time I will update this. You can join this to get those updates. Hope you like this video and thanks for watching.